ever find yourself like needing a quick geometry refresher?
Yeah.
Like maybe when you're at the store and you're trying to figure out like, how much fencing do I need for my garden? Or you're ordering pizza for a group and you're trying to figure out how much pizza you need, how many pizzas to order.
Right, yeah.
We're doing that today. We're diving deep into the surprisingly practical world of perimeter and area.
Okay.
And trust me, this isn't just a rehash of like 6th grade math. This is the real deal.
Okay.
So to help us out on this deep dive, we are joined by...
I'm Expert's Name. I'm happy to be here.
Welcome. So you'd be surprised how often these like very basic concepts
Yes.
actually pop up in our everyday lives, right?
Absolutely. All the time.
So to illustrate this, we have a real life dilemma
Okay.
from our friends Ayush and Diksha.
All right.
Okay. So Ayush and Diksha are both working on art projects.
Okay.
Ayush has a rectangular sheet of paper, and it's 60 centimeters by 20 centimeters. Diksha's got one. It's 40 centimeters by 35 centimeters.
Right. All right.
Okay. Now they both need to frame their artwork,
Okay.
and they also both want to laminate it.
Okay. Makes sense, yeah.
So here's where the geometry comes in.
All right.
Framing costs 3 rupees, I should say, per centimeter.
Okay.
Lamination, on the other hand, it's priced at 2 rupees per square centimeter.
Right.
So who's going to have to shell out more cash?
Right.
Ayush or Diksha?
Yeah.
What do you think?
Well, that's where we need to consider these concepts, right?
Sure.
So perimeter versus area.
Yes, exactly.
Right.
Like,
So the perimeter is going to be that framing cost because we're looking at the distance around the artwork.
exactly.
Yeah.
It's like measuring for a border.
Right.
Or for a frame.
Yes, absolutely.
And then the lamination is all about the area, right?
Precise.
Because you're covering the whole surface.
Exactly. Covering that whole surface.
Like wrapping paper.
Exactly. Yeah, like wrapping a present, right?
Yeah.
You need to know how much paper to cover it.
So before we solve Ayush and Diksha's cost, conundrum, right?
Right.
Let's just do a few scenarios just to kind of get everybody, up to speed.
Okay. Sounds good.
Okay. So imagine a blackboard, right?
Yeah.
A blackboard taking up space on a wall.
Right.
Are we talking about the perimeter or the area of that blackboard?
What's your gut feeling on that one?
I mean, it's got to be area,
It
right?
has to be area. Right. Yeah. We're talking about the space that it's covering on the wall.
Exactly. Yeah, the surface.
Exactly.
Okay. How about this? You're putting you're installing a fence around a flower bed,
Right.
and the flower bed is a rectangle.
Okay.
Do you need to know the perimeter or the area to figure out how much fencing to buy?
Definitely perimeter there.
It's got to be the perimeter.
Yeah.
Because we're measuring all the way around.
Exactly. We're adding up the length of all those sides, right?
Totally.
To figure out the total length of fencing we need. Okay.
All right.
Last one.
Okay.
Okay. So you're a marathon runner, and you're doing 2 laps around a park, and this park happens to be a triangle,
Okay.
triangular park.
Right.
To figure out, how sorry you've run,
Hey.
total distance,
Yeah.
perimeter or area.
That's going to be perimeter again.
Perimeter. We're talking
Yeah.
about the distance
Yes,
around.
exactly. The total distance that you've covered around the edges of the park.
You got it.
Right.
Right. So you're already basically like a geometry whiz.
Oh, I don't know about that.
Okay. Well, let's add a little layer of intrigue here.
Okay.
Okay.
All right.
A little puzzle.
I like it. Okay.
So imagine we've got Tanya. Okay.
Okay.
She's creating a collage,
Right.
and she's using a sheet of paper. It's a rectangle, and it's 28 centimeters long, 21 centimeters wide.
Okay.
Now she cuts out a square from one corner of this paper,
Okay.
and the square is 4 centimeters by 4 centimeters.
So here's my question. Did cutting out that square make the perimeter of the remaining paper increase or decrease?
That's a good question.
Yeah.
What do you think?
I think this is one where, initially you would assume, because she's removing paper,
You would think it decreases, right?
you would think it decreases. But I have a feeling that's wrong.
Yeah, and you're right to question that initial instinct because actually the perimeter increases.
Wait, hold on. It increases,
It does.
even though she's taking something away.
Even though she's removing paper, the perimeter, the total distance around the outside of the shape actually gets bigger.
How is that possible?
It's all about those new edges that are created when we cut out that square. So she's removed a square, but in doing so, she's added 2 new sides to the shape.
Oh.
Right.
So those new sides add to the perimeter.
Exactly. They add to the overall perimeter. And even though she's removed some length, those new sides actually make it longer overall.
So even though the sheet is technically smaller in terms of area, the perimeter can actually be larger.
Precisely.
That's amazing.
It's a great example of how our intuition about shapes can sometimes be a little bit misleading.
Totally.
Right. And here's another little curveball for you. If Tanya were to cut out another identical square, so another 4 by 4 centimeter square from the opposite side of the sheet,
Okay.
the perimeter would increase again.
No way. This is blowing my mind. Okay, so perimeter and area, they don't always play by the same rules, even though they're both about shapes.
Exactly. They're interconnected, but they don't always change proportionally.
Yeah.
And this idea actually leads us to some other interesting territory, particularly when we start exploring other shapes.
Okay, before we go too far down the rabbit hole,
Sure.
can we just go over the formulas for squares and rectangles?
Absolutely. Yeah, let's do a quick review.
Just so we're all on the same page.
Okay, so for a square, the perimeter is simply 4 times the length of one side.
Right, because all the sides are the same.
Exactly. All sides are equal.
And then for a rectangle, it's the length plus the width, and you multiply that by 2,
You got it.
since the opposite sides are equal.
Precisely. Opposite sides are equal in a rectangle. Now, how about area? For a square, it's even simpler. It's just the side multiplied by itself, or side squared.
And for a rectangle.
Length times width, a classic.
Okay.
Now, are you ready to venture into the realm of parallelograms?
Ooh.
They might seem a bit trickier than squares and rectangles, but trust me, finding their area is just as straightforward.
Okay, because parallelograms always kind of intimidated me a little bit, I have to admit.
Here's the key.
Yeah.
Think of a parallelogram as a rectangle in disguise.
Okay.
You can actually transform any parallelogram into a rectangle with the same area.
Wait, really?
Absolutely.
Yeah.
Imagine this. You slice a triangular section from one side of the parallelogram and then shift it over to the other side.
Oh, like a puzzle piece.
Exactly. And suddenly, you've got yourself a rectangle. But here's the crucial part. The height of that original parallelogram. That's key.
So we're not using the length of the slanted side.
Nope. It's all about the perpendicular height, just like with a rectangle. And to calculate the area of a parallelogram, all we need is the base and that perpendicular height.
Okay, that's making more sense now. And guess what? This parallelogram knowledge unlocks a secret about triangles, too.
You're reading my mind. The area of any triangle is always half the area of a parallelogram that shares the same base and height. We'll visualize this more later, but for now, just imagine that every triangle is like half a parallelogram hiding in plain sight.
That's so cool. So by understanding parallelograms, we're actually unlocking secrets about triangles, too. I love how it all connects.
Exactly. Geometry is all about those surprising connections. But before we get too far ahead of ourselves, let's circle back to Ayush and Diksha's framing dilemma. Remember, Ayush's artwork is 60 centimeters by 20 centimeters, and Diksha's is 40 centimeters by 35 centimeters. Framing, that's where perimeter comes in, at a cost of 3 rupees per centimeter. Let's crunch those numbers and see who's shelling out more for that frame.
All right, time to put those formulas to work. Let's tackle Ayush's framing cost first. His rectangle is 60 centimeters by 20 centimeters, so we add those dimensions and multiply by 2 to get our perimeter.
That gives us a perimeter of 160 centimeters for Ayush's artwork, and since framing costs 3 rupees per centimeter.
That brings his total framing cost to 480 rupees. Now for Diksha, her rectangle is 40 centimeters by 35 centimeters.
Adding those dimensions and multiplying by 2, we get a perimeter of 150 centimeters for Diksha's artwork.
And at 3 rupees per centimeter.
Her framing cost comes out to 450 rupees.
So it looks like Ayush takes the lead, or rather, spends the lead in the framing department.
For now, anyway. But don't forget, we still have those lamination costs to unravel, and that's where area takes center stage.
Oh, this is getting interesting. All right, deep divers, we're just getting started. Stay tuned, because in part 2, we're diving into those lamination costs, uncovering the wonders of circles, and even exploring some real-world applications of these geometric principles.
Now let's shift gears a bit.
Okay.
From straight lines and corners. Okay.
To the world of curves.
Ooh, curves. Okay.
Yeah, you ready for this?
Yeah, I mean, circles always kind of, threw me for a loop, you know.
Yeah.
Back in geometry class.
Yeah, circles can be a bit unique, that's for sure.
Yeah.
But just like with parallelograms and triangles,
Okay.
there are these key concepts that kind of unlock their secrets.
Okay.
So we can totally handle this, you know?
Yeah. Where do we even begin with circles? I mean, my ruler never knew what to do with those curved lines.
I hear you. That's where circumference comes in.
Circumference, okay.
Yeah, think of circumference as like the perimeter of a circle.
Okay.
It's the total distance around that curved line.
Okay.
Imagine, you're wrapping a ribbon around a circular cake
Right.
to see how much you need.
Yeah.
It's basically finding the circumference.
Okay, so instead of measuring every little, like, curve and bend, there's a better way?
Yeah, exactly. Mathematicians, they figured out this fascinating relationship.
Right.
There's this constant ratio.
Between a circle's circumference and its diameter.
Okay, the diameter, that's the line that cuts right through the center of the circle, right?
You got it straight through the center.
Okay, and you said a ratio.
Yeah.
So, like, no matter how big or small the circle is, the relationship between its circumference and diameter is always the same.
Exactly. It's mind-blowing, right?
Yeah.
And this magical ratio, we represent it with the Greek letter pi.
Pi.
Pi. You know,
It's like the rock star of math. Everybody knows pi.
exactly.
I'll be honest, I could never remember what it actually was.
So a lot of people just remember it as 3.14,
Right.
which is pretty good approximation, you know?
Yeah.
But what's really cool is that pi is actually an irrational number.
Okay, irrational, like it just keeps going.
Yeah, those decimals, they go on forever without repeating.
Wow, that's kind of trippy.
It's a never-ending number that helps us understand circles.
That's amazing.
I know, right? Even simple shapes, like hold these hidden depths. So how do we actually use pi to, work with circles? Remember that constant ratio we talked about? Well, pi equals the circumference of a circle divided by its diameter.
Okay, so if we know the diameter in pi, we can figure out the circumference.
Exactly.
And since the diameter is just double the radius, we can use the radius too, right?
You got it. The formula is 2 times pi times the radius.
Got it. What about the area of a circle? Does pi help us out there too?
It does. That space inside the circle's boundary, that's the area. We calculate that using pi as well.
Okay, so tell me, how do we figure that out?
The formula is pi multiplied by the radius squared.
So pi is the key, once again.
Pi always comes to the rescue with circles.
I love it. Okay, so now that we've got all this pi knowledge, can we go back to Ayush and Diksha's art projects?
Of course, we still need to figure out who's spending more on that lamination.
Right, we figured out their framing costs using perimeter, but lamination, that's all about the area.
Exactly.
Ayush's sheet is 60 centimeters by 20 centimeters.
Okay.
Diksha's is 40 by 35 centimeters. All right. And remember, lamination is 2 rupees per square centimeter.
Right.
So who's paying more?
Well, it might seem counterintuitive,
Okay,
but Diksha's lamination costs are actually going to be higher.
really? But her sheet seems smaller.
It did seem smaller at first glance, but when we calculate the actual area, you'll see why.
Okay, let's do the math.
All right, so Ayush's sheet, its area is 60 centimeters times 20 centimeters, which comes out to 1,200 square centimeters.
Okay, 1,200 square centimeters.
And then we multiply that by the lamination cost, 2 rupees per square centimeter.
Right.
That brings Ayush's total lamination cost to 2,400 rupees.
Okay, so Ayush is at 2,400 rupees for lamination.
Now, let's see how Diksha compares.
Okay.
Her sheet's area is 40 centimeters times 35 centimeters, which gives us a total of 1,400 square centimeters.
Okay.
Multiply that by the 2 rupee lamination cost,
Right.
and her total comes out to 2,800 rupees.
Wow, you were right. Diksha's lamination is more expensive, even though her sheet seemed smaller at first.
It's another example of how perimeter and area can have these surprising outcomes.
Yeah, you really can't judge a shape by its sides, I guess.
Exactly. Sometimes you got to dive into the math to see the full picture.
I love it. Geometry is full of surprises.
It always keeps us on our toes.
So now that we've tackled those costs, are you ready for some more real-world circle challenges?
Bring 'em on. I'm ready to put this pi knowledge to good use.
All right, hit me with a real-world circle challenge. I'm ready.
Okay, imagine this. You're an architect designing a stunning new amphitheater.
Nice. I like where this is going.
And of course, you'd go with a circular shape for that optimal acoustic experience.
Makes sense.
Your stage is right in the center. Now, you want to make sure everyone has a clear view, so you decide to build the seating area on this raised, semicircular platform.
Okay, I'm picturing it.
The question is, how much material do you need to cover this entire platform?
So we're basically trying to find the area of a semicircle, right?
Precisely. And that means it's pi time.
All right, pi to the rescue. So how do we tackle this? It's not a full circle after all.
We can still use our trusty circle area formula, pi times the radius squared. We just need to adapt it for our half circle situation. We calculate the area as if it were a full circle and then simply divide it in half.
Ah, I see. So let's say the radius of this amphitheater platform is 10 meters. What would the area of our semicircular platform be?
Okay, let's plug in those numbers. A full circle with a 10-meter radius would have an area of pi times 10 squared, which is pi times 100, giving us approximately 314 square meters.
So 314 square meters if it were a full circle? But we only need half of that, right?
You got it. Divide that 314 square meters by 2, and we get 157 square meters. That's how much material our architect needs.
Problem solved, thanks to pi. Thinking back to Ayush and Diksha's art project, it's amazing how these geometric concepts pop up everywhere.
It really goes to show how deeply ingrained these principles are in our world. From everyday objects to these incredible architectural feats. And speaking of Ayush and Diksha, remember how their framing and lamination costs played out?
Oh yeah. Ayush, with his larger 60 by 20 centimeter sheet, actually ended up paying less for lamination than Diksha, who had the 40 by 35.
Exactly. Even though Disha's sheet looks smaller at first glance, its total surface area was larger, and that's what determined the lamination price.
Such a good reminder that appearances can be deceiving. We can't always rely on visual estimations when it comes to shapes. Sometimes you have to dive into the math to get the whole picture.
Absolutely. It's all about looking beneath the surface. And that's what makes exploring these geometric concepts so fascinating.
Couldn't agree more. From parallelograms and triangles to the wonders of pi, we've seen how these principles shape our world in ways we might not always realize.
And it's all about making those connections, right? Linking those seemingly abstract concepts to their real-world applications.
Exactly. So to all our deep divers tuning in, we hope this episode has inspired you to see the world with a fresh, more geometric perspective. Because geometry is everywhere, whether you're tackling a DIY project, admiring a building, or just appreciating the beauty of a perfect circle. Keep those minds curious, everyone.